Hello guys, welcome to our next lesson. We've just taken a quiz over different properties and different operations with polynomials. So we've talked about adding and subtracting and multiplying those polynomials together. Today what we're going to start doing is we're going to start doing the opposite of those things. We're going to start taking them apart. And that process, when we talk about polynomials, is called factoring. And so what we're going to be working on for the next few days is factoring polynomials in different types of ways. So that today we're going to look at the first method, which is called factoring by the GCF. So just to get us thinking about this, my first question is, what do I mean when I say what are the factors of 24? So that may be a word you're not quite familiar with, but factors simply means what are the pieces that make up 24 by multiplication. And so if I were looking for factors of 24, I'd go in a very organized fashion. I'd say the first factor is 1 and 24. 1 times 24 gets me 24. And then I'd say 2 and 12 because 2 times 12 also gets me to 24. 3 times 8 and 4 times 6. So the list of factors would be 1, 2, 3, 4, 6, 8, 12, and 24. So you try the next one. What are the factors of 42? All right, I hope you came up with 1 and 42, 2 and 21, 3 and 14. 4 is not a factor of 42, neither is 5, but 6 and 7. And I know I'm finished with my list of factors. If I do it in this organized manner, I know I'm finished because my next number would be 7, and that's already on my list. All right, let's try one last one. Can you now look at those two lists and come up with the common factors of both 24 and 42? So let me put these back up here. 24, 12, 8, and 6. What are the common factors of 24 and 42? And so when I ask that question, what I'm looking for is what numbers are on both lists. So I see 1 on both lists, I see 2 on both lists, I see 3 on both lists, 6 is on both lists, 7 and 4 and 8 are not, 14, 21, 42. So it looks like the common factors would be 1, 2, 3, and 6. So that's the basic idea of what we're going to be looking at as we begin to try to factor our polynomials. All right, so the first question, or the types of question you're going to see today, look like this. It says, what is the greatest common factor of these terms? And so basically what they're asking is, what do we see that all of these terms have in common? Now, some of you may be able to just look at this and be able to see numbers and x's that they all have in common, but for some of us, it's a little bit harder to see that. And so I'd like for you to do just what we did on that last slide. List your factors in each term and then look for what's in common. So if I do that, starting with 12, I would say 1 and 12, 2 and 6, 3 and 4. And then x to the 5th would mean I have 5 x's out here. All right, 8, I would say 1 and 8, 2 and 4, and then x to the 4th, I'd have 4 x's. And finally, when I look at 6, I'd say 1 and 6, 2 and 3, and then I'd say x to the 3rd. All right, so looking for the greatest common factor. Now what I'm looking for is what is the biggest number that they all have in common. So I start at the biggest. They don't all have a 12. Then I go to 6. They don't all have a 6. I go to 4. They don't all have a 4. I try 3. 2 of them have a 3, but not all 3. And so the biggest number that I see that is on all 3 of these lists is a 2. So that is going to be part of my GCF. All right, now I look at the x's. I want to circle the most number of x's that I can in each one of them. So I can circle all 3 here, I can circle 3 here, and circle 3 here. So what I've circled becomes part of the greatest common factor. So in this case, the greatest common factor would be 2 and x to the third. Remember, greatest common factor means the biggest number or biggest number of x's that all the terms have in common. Why don't you try this one on your own just to see where you're at. See if you can find the greatest common factor of 15x squared plus 18. All right, so listing these out, 1 and 15, 2 doesn't work, but 3 times 5 gets me 15. 4 doesn't work, and I'm back to 5. And then I've got x times x. 18, I would say 1 and 18. 2 and 9, 3 and 6, 4 doesn't work, 5 doesn't work, and I'm back to 6. And no x's over here. So looking for the biggest thing that they both have in common, what I'm seeing is a 3 and no x's because this second term has no x's. So my greatest common factor is just the number 3 in this case. All right, finally, let's try one more. Can you find the greatest common factor of negative 18y to the fourth plus 6y to the third plus 24y squared? Again, as you work through this, that 18, and I'm not so worried about the negative sign right now. We can worry about that if we want, but I'm just going to worry about the numbers right now. So 1 and 18, 2 and 9, 3 and 6, 4 and 5 don't work, and then y to the fourth would be 1, 2, 3, 4 y's. 6 would be 1 and 6, 2 and 3, and then y to the third would be 1, 2, 3 y's. And 24 would be 1 and 24, 2 and 12, 3 and 8, 4 and 6, and then I'd have y and y. All right, so starting with numbers, I'm looking for the largest number they have in common. So I'm starting over here with 18. They definitely don't have 18 in common. No 9 in common. 6 I see in 2 of them. Oh, I see it in all 3 of them. So I think 6 is going to be the greatest number that they all have in common. Now, in this case, there are other numbers they have in common, like 2 and 3 and 1, but we're looking for the biggest, the greatest common factor. All right, looking at y's. The biggest number of y's I can circle here is 2, and so I look and see, yep, I can circle 2 in all of those. So that means my greatest common factor is 6y squared. Now, sometimes you'll see when that leading coefficient, that beginning number is negative, they'll want you to say that you're pulling, or your greatest common factor is a negative 6y squared. It just helps us keep things organized in a different way. And so just know that as you do your Pearson assignment, if you try that 6y squared and it tells you that that's not correct, you might come back and try that negative instead. All right, so the last step of this process is now factoring out the GCF. So it starts the same way. We find the GCF, and then what we're going to do is write that GCF, but also show what's left over once you do that. So the way that that works is this. We start the same way. So x to the third would just be x times x times x. 5x squared would be 1 times 5, and then x times x. And then negative 22x would be 1 and 22, 2 and 11 with just an x. All right, so looking at these, I don't see any numbers that they all have in common, but I do see the x that they all have in common. So what they have in common, the greatest common factor, I'm going to pull out in front of the problem. Then I'm going to leave a set of parentheses, and I'm going to write down inside what's left over. So if I took this x out, I'm left still with 2 x's, or x to the second power in that first term. Okay, up here, I didn't take any numbers out, so I'm still left with 5, and I still have an x left in that one. And then finally over here, I didn't take out any numbers, so I'm still left with the minus 22, but I did remove the x. Guys, the goal of this is what should happen is if I now went and multiplied, I should get back to the same answer. So if I distributed this property or this xn, I should get x to the third plus 5x squared minus 22x. That's my factored form because I've pulled out what they have in common and showed what they have left over on the inside. Guys, factoring is just the opposite of multiplication. Let's try another one together. All right, in this case, we're looking for what they have in common. So again, I'm going to start with my numbers. So 1 and 16, 2 and 8, 3 does not work, but 4 and 4 works. And then y to the 6 means I'd have 6 y's listed out here. All right, moving on to 28y to the 4th, I'd have 1 and 28, 2 and 14. 3 doesn't work, but 4 and 7 does. I don't think 5 or 6 is a factor of 28, so back to 7. And then y to the 4th would be 4y's. Then finally, negative 20y to the 3rd, I'm going to start with factors of 20, so 1 and 20, 2 and 10. 3 is not a factor of 20, but 4 and 5 are, and then I'd have y times y times y. So again, I'm looking for what they have in common. Number-wise, starting with 16, I don't see that. I don't see 8 on the list, but I do see 4 on every one of my lists. So we'll say 4, and then I go to the y's. I see 3 y's here. I can circle 3 y's here and 3 y's here. So that looks to be part of my greatest common factor. Now, this is one of those that has a negative leading coefficient, so that means I'm going to factor out the negative. So negative 4y to the 3rd is going to be my greatest common factor. So if I make this 4 negative, this 4 would still be positive because negative 4 times positive 4 would give me that negative 16. So I'm still going to be left with a 4. And I'm still also, because that's what matches here, and I'm still also going to be left with y to the 3rd. Again, I can test this because if I distributed in, negative 4 times 4 would be negative 16, and y to the 3rd and y to the 3rd would be y to the 6th. All right, same thing. Now, if I make this 4 a negative, because that's what I've pulled out, I would need to make the 7 a negative to make it a positive 28. So negative 7, and then I just have one y left over that I didn't circle. And then finally, if I make the negative, or the 4 negative, because that's what I'm pulling out as my GCF, my 5 would stay positive because negative 4 times 5 would get me that negative 20. So positive 5 and no y's left over. Guys, I know, I can check this by distributing and making sure I get back to my original. And I can know that I have found the greatest common factor if when I look inside the parentheses, I don't see anything else in common. So when I look at these numbers, 4, 7, and 5, nothing in common, and I don't see y's on every one of those terms. That means I've pulled the correct number of y's out front. All right, so let's just talk a couple of things in review. When they ask for the greatest common factor, if I have two polynomials that don't have any common factors, let's just look at an example. That would look something like 3x squared y plus 5z. If I look at that, 3 would be, my factors would be 1 and 3, x squared, I'd have 2 x's and I'd have 1 y. And over here, factors of 5 would be 1 and 5 and then just a z. When I look at that, it doesn't look like there's anything in common except for a 1. And so the greatest common factors of two polynomials that don't look like they have any common factors is in fact just a 1. And if I factored out that 1, I would be left with just the same thing, 1 times 3x squared y plus 5z. Nothing really changed. One last question. This one says, Andrew factored 3x squared y minus 6xy squared plus 3xy as the greatest common factor being 3xy. And then what was left over inside is x minus 2y. Now I want us to take a look at this because if we were checking Andrew's work and I distributed in, I would end up with 3xy times x, which is 3x squared y. Good start. And then 3xy minus 2y would be negative 6xy squared. Again, great start. But the problem is I'm missing that third term. And so if Andrew were actually going to do this, he is absolutely correct that the greatest common factor is 3xy. But then what I would be left over with is an x minus 2y, and then I need that plus 1 so that when I distribute, I get that 3xy as one of my terms of my original problem. All right, guys, I hope this helps. This is going to be one of those things that it's going to take some practice. And so as you work through your problems, if you're missing them, make sure you're reading that box that pops up when you have missed it, because it gives you some hints. It tells you what you're doing wrong, and use that as a learning tool to then try another problem. This is never our intent for you to be confused and working on homework for hours upon hours. And so if you're trying and you're stuck, this is when you need to reach out, and Mr. Jordan and I would be happy to meet with you to try to help you get on the right track. Often that doesn't take long because it's often just a small misconception that we need to clear up. Guys, I hope you have a great day and enjoy this new process. We worked on putting polynomials together. Now we're beginning the process of taking them apart, which is called factoring.